Today we're looking at notes 3-3, solve systems of linear inequalities. So the objective today is to graph systems of linear inequalities and decide if points are solutions to the system. So two or more inequalities using the same variables are called a system of inequalities. The points that make both equations true, the points that make both inequalities true are located in the region that is shaded twice. Okay, so to find the solution to a system of linear inequalities, you will first graph the solution set of the first inequality, then graph the solution set of the second inequality, and the solution set of the system of linear inequalities will be the region that's shaded twice, and we will definitely look at that here. So looking at example number 1, solve the system of inequalities by graphing. So we are given this linear system of inequalities, okay, and our step number 1 to find the solution of the system of linear inequalities would be to graph the solution set of the first inequality. So we are going to look at the first inequality. I'm going to put it off to the side here. Y plus 2x is less than or equal to 4. And you're going to get this in slope-intercept form just as if you would if this was an equal sign and not an inequality. So on this, you're going to do, just like I said, like you would do if it were an equation. So in other words, move over the positive 2x, but put it directly in front of the 4. So this will be y is, drag the y down, the less than or equal to will drag down. When that positive 2x goes over the inequality, it becomes negative 2x. And the plus 4, the positive 4 just scoots over. Now we have slope-intercept form. So we've got this inequality in slope-intercept form, so we're going to graph the y-intercept of 1, 2, 3, 4. And then our negative 2 slope means we're going to go down 2, right 1, down 2, right 1. And I know I only require 3 points, but for these inequalities, you're going to want to fill the graph with points. It just makes the shading easier. Okay, so before I get out my straight edge, we need to talk. So this inequality has the or equal to, so that means we will have a solid line. So solid line, not dashed. So solid line, arrows on both ends. Now we need to talk about shading. So less than or equal to means I'm coming over to the y-intercept and I'm going to shade below. So below my graph here. That's what less than means, below. So and if the graph were way up here, then this would be below, of course. So just shade the portion of the graph that would be below. Okay, now, so we did number 1, we graphed the solution set of the first inequality. We've done that. We graphed the solution set of the first. Now let's go to the second. So I'm just going to go directly below this line here. So notice I'm not in slope-intercept form quite yet because y isn't completely by itself. All right, so I need to get rid of the negative 2 by dividing every single term by negative 2. So that's why here you will share the love. Okay, so when with an inequality, hopefully you remember, when I divide by a negative, I'm dividing by a negative. Of course, here the negative 2 divided by negative 2 turns to 1. So 1y, we don't write the 1. But when I divide by that negative, that symbol switches. So instead of less than, this will become greater than. And then negative 2x divided by negative 2 would be positive x. And positive 6 divided by negative 2 would be negative 3. So I should box these final answers. Okay, so box that, box this. And let's come over here and start graphing. So minus 3, negative 3 is my y-intercept. So 1, 2, 3. And then my slope is positive 1. So up 1, right 1, up 1, right 1. And you'll notice today, unlike when we were doing the systems of equations, the inequalities won't always intersect at an exact integer value. Okay, so your intersections will probably be fractional or decimal, however you want to think of it, values, not integers. Okay, so before I get my straight edge, remember I look at my symbol. So this is not or equal to, so I will not draw a solid line. I will draw a dashed line. So I just typically connect every other dot. That's how I do a dashed line, but to each his own. Okay, so there's my dashed line. Now the shading. So that symbol is greater than. So I'm coming over here to the y-intercept and I'm going to shade above. Greater means above. So above the graph. Above. And then, like number 3 says, we've already done number 2. We've graphed the solution set of the second inequality. Like number 3 says, the solution set for the system of linear inequalities is the region that is shaded twice. So I used red and blue on purpose. It didn't turn out as well as I had hoped, but red and blue are supposed to come together and make purple. So I'm going to mark the double shaded region. So this region right here is the only region that has both red and blue shading. Notice this only has blue in this section, this only has red in this section, this has both. So it comes together and makes purple, that's why I'm using purple. And I'm putting an S here for the solution set area. So that is the solution set area. Okay, now we're gonna do what it talks about right here. And we're going to test the points that make both inequalities true are located in the region that is shaded twice. So you should be able to pick any ordered pair from this solution set region, and you should be able to plug it into both inequalities, and it should work. It should make a true statement, So now I would never want you to take this point and plug it into your newly solved inequalities, because what if you made a mistake here? Then that doesn't help. So you're going to take an ordered pair. So the ordered pair, I'm just going to use 0, 0 because that's an easy one to use. You see the ordered pair 0, 0 lies in the solution set. Let's test. Let's test it. Okay, so we're going to go back to the original inequalities. So come up here. So we're going to take y plus 2x is less than or equal to 4, and we're going to take negative 2y is less than negative 2x plus 6. So we took the original inequalities, and I'm going to plug in 0, 0. Remember, this is x, this is y. So y is 0, x is 0. Okay, y is 0, x is 0. Plug it into both. It's got to work for both, all right? Not just one, but both. If it's a solution to the entire inequality, the system of inequalities, then it should work for both. This is 0 plus 0 is less than or equal to 4. Is that true? All right, because here 2 times 0 is 0, and yes, that's true. 0 is less than or equal to 4. That's true. Okay, here this is negative 2 times 0, which is 0. 0 is less than negative 2 times 0 is 0 plus 6. So is 0 less than 6? Certainly is. So we just checked a point in our solution set. Okay, so I'm not going to show that part again, probably. We'll see if we have time. But I have another example for you. So this is kind of an odd example. So looking at the system of linear inequalities, okay, we've got y plus 4 is less than or equal to 0. There's no x here, but I need the variable by itself and I need it on the left. So I'm going to write y plus 4 is less than or equal to 0. Rewrite it. All right, okay, and I'm going to move this positive 4 across the equal sign. It will become negative 4, and when combined with the 0, it's just 0. So y is less than or equal to negative 4. Nothing else I can do with that. Okay, remember, y equals negative 4 would be your horizontal line that cuts through the y-axis at negative 1, 2, 3, 4. So right here, there's my 3 points. It does have the or equal to, so we do draw a solid line. Okay, arrows on both ends, and that's less than. So we will shade below the line. Below the line. Okay, so now for this For this inequality, we have an issue. I said before, you want the variable by itself and you want it on the left. The variable is certainly by itself, but it's not on the left, so you need to switch sides. So this is going to become x is greater than -2. So I've just switched sides of the variable and the number, so the inequality should switch with it. The mouth should still open towards the x like it does here. So then this is x is greater than -2. So remember, x equals -2 is a vertical line through passing through the x-axis at -2. So now got my points here. I've got a couple of points. I'm putting them every other. And this is a dashed line because we don't have the or equal to. So make sure you just do dash, not solid. Okay, so not a solid line on this one. All right, and then greater than, in this instance, there's no above or below the graph because the graph runs down and up. It's a vertical line. So for x is greater than -2 for this type of line, well, where are your x values greater than -2? That would be on this side of the graph. So everything to the right. Now I want you to be aware, please, please, please hear me when I say you never think of greater than or less than as to the right or to the left. It's always above or below, except, of course, in math, there's always that one exception, except when you have the x equals graph. That's the only time you will think of greater than or less than being above, left or right and not above or below. So my double shaded region is here, the solution set. I will mark it. If you wanted to test a point in this solution set, I'd say something easy like test the coordinate 0, -1, 2, 3. Could you test 0, -4? That's an interesting question because -4 lies on the solid line. If a point lies on the solid line, is that okay? Is that included in the solution set? Hopefully you would say yes, but you could always test it and see. So remember, that's x and that's y. And remember, when you're testing, you're not using these because you might have made a mistake on these, and that would ruin the test. So you have to test with the original. So y plus 4 is less than or equal to 0, and -2 is less than x. So let's see. On this one, you only have to plug in y. So is that a true statement? -4 plus 4 is 0. Is 0 less than or equal to 0? Certainly is. And then on this one, you only have to plug in x. -2 less than 0. Is that true? Yes, it sure is. So 0, -4 is a solution, is a point in the solution set. It was included because it lied on the solid line. Now, if it was on the dash line, wouldn't be included. Wouldn't hold true.